following problem. Consider the configuration below. The magnitude of the B field is B, the rod speed is V, and the rod's length is L. What is the induced EMF of the circuit? If the resistor has resistance R, what is the force needed to move the rod at constant speed? All right. So this problem is actually a very simple but classic problem. Okay, so let's basically draw a line. This thing's moving with speed V. This length here is the length L. All right, and the magnetic field is magnetic field B. All right, and that's all we need to know. Okay, and this resistor is resistor R. Okay, so let's write down the equation for the EMF. The EMF is equal to minus d phi dt, where this is the magnetic flux. Magnetic flux is just defined as basically the magnetic field times the area. It's a uniform magnetic field, so it can be basically minus dB times A dt. But magnetic field is constant, so it's just going to be minus B d by dt of A. Okay, at this point, it's helpful to basically realize what's the area that is in question. The area that is in question is here, right? And what we really want is basically how that area is changing as a function of time, right? So to make it simple, let me just define basically x is starting from this resistor onward, and so this would be basically minus b times d. What's the area of this rectangle here? Well, this is just going to be L times x, but L is a constant, so it's going to be minus BL dx dt. And what is dx dt? But velocity. So this is basically minus BLV. Alright, now this formula you've probably seen in class already, alright, but it's good, helpful to derive this chain of logic to see how this is arrived at. Now, to get the rest of it, okay, let's suppose that this resistor has resistance R, okay? What's the force needed to basically move the rod at constant speed? Well, because this resistor has a constant R, there's a certain power that gets put into this resistor. What is that power? The power of the resistor, P, is just going to be the EMF squared over R. Okay, I'm not using V here because we're using a V here, right? That's just a bad idea to mix these two, right? But one V will be velocity, this V, this EMF here will be a voltage, right? You could use capital V as well, but you gotta keep track of the two. This power, which we imagine is basically applied by a force here, all right, which is dragging this rod along. The power is also equal to force times the velocity. Okay, so let's basically just plug everything. So the EMF is this one. That's going to be BLV squared over R. This is equal to F times V, right? And so what this gives you is basically this gives you B squared L squared V squared over R is equal to FV, or in other words, F is equal to subtracting eliminating one factor of V on both sides, B squared L squared V over R. Okay, hope that was helpful.